Hello students. In this session, we are discussing about k-means. And k-means is an unsupervised algorithm. Let us try to see that how does k-means algorithm works. Here you see that we have k and means. So we have two terminologies. Now k basically means that number of groups or number of clusters we want. Let's say in front of you there are 100 people and you want to group them. So, first of all, you need to know that how many groups do you need to create, and that is K. Means is centers or centroid. For example, if you create one group, then there has to be one center value, a mean value for that particular group. And we expect that all the elements or all the data points of that particular cluster should be nearer to that particular centroid or center. So normally how do we start with k-means algorithm? We assume the value of k. We start by assuming the value of k. But after that, we need to find the centroids. So let's say if I basically identify the value of k as 2, in that particular case, I need to identify two center values. And now these two center values can be assumed from the data set. Whenever we are assuming, then further mathematical computations are happening, and then we are computing the new center values. So k-means is an iterative process. First of all, with certain assumptions we start, but as soon as we move ahead, it works completely on mathematics. I'll be explaining you all that. Let us try to understand what exactly we expect. As I told you, if I keep the value of k as 2, so I will have cluster 1 and I'll have cluster 2. All the data points which belong to cluster 1, they should be nearer to each other. In similar way, all the data points which are in cluster 2, they should be nearer to the centroid of the cluster 2. I have highlighted the centroids. Here you can see. Now let us see mathematically how does it happen. Let us take some data points. We can call them as x. Normally we call our data points as x. So I have some values as 1, 2. I have one value as 45. I have another value as 102 and one more value as 132. So these are the 5 values as input values I have. Now I have to decide the value of k. Let's say k is 2. I have assumed. There is a way also to find k, and that actually we need to use. But as of now, to make it very simple, I'm just making it 2. So now what is going to happen? Now we will have a cluster 1 where we need to choose a centroid. So I'm taking a centroid as 1, the center value as 1. There has to be a cluster which is C2, and I'm taking the centroid value as 2 because initially we need to assume. So I have made these assumptions. Now what further should happen? Now further, I should be able to calculate the distance from the center to all the data points, which means that this center value is 1. So from 1, I need to calculate the value of the distance of this 1 from 1, 2 from 1, 45 from 1, and I should actually take up an absolute distance. Because if I don't take absolute distance, then that might create some problem. So from the beginning only I'm taking an absolute distance. So ABS is equal to 1 is the center value minus this particular 1, and the value is 0. Similar way, here also I'll take is equal to absolute value, and 1 is the center point minus this 2 value. So this is how I'll be doing for all the data points. So here you can see that I have got the distances. Exactly the same way, I will calculate the absolute distance from 2 to all the data points, and this is how I will get the values. Now what is the next step we need to do? Next step, we need to check that out of these values, which values are actually nearer and which values are farther. That means which values are near to the cluster centroid and which value are farther away. So if you see from 0 and 1, we know that 0 is nearer. So let me give it a different color. And then from 1 and 0, 0 is nearer, 43 is nearer, 100 is nearer, 130 is nearer. So what I have done is I have given them a blue color so that we can understand that what kind of clusters are to be formed. And here you can see that our cluster 1 is having only one value, and rest of the values are there in cluster 2. So all these values are present in cluster 2. So these are the clusters which we have formed. Now, is this the final cluster? The answer is no, this is not the final cluster. So how to compute the final cluster? To compute the final cluster, find the average. Find the average of the data points present in the first cluster. So the average is 1. Very similar way, find the average of the data points which are present here. Find the average. So we have got two center points here. So earlier the center points were C1 is equal to 1. So for cluster 1, the center point we assumed as 1. For cluster 2, center point we assumed as 2. But now we have got some center points which we have got from the data itself. So let me go for the second iteration. So this was the first iteration. So iteration iteration 1. Let me go for the second iteration now. For second iteration, everything is going to remain same. The only thing is our center values are going to get changed. So let us go for the second iteration. And here, this is iteration iteration 2. The center values are going to get updated. So the center values are, here in case of C1, it is 1 only. But in case of C2, if you see, it is going to be 70.25. And accordingly, the formula is also going to get changed. So ABS, absolute value, 70.5 minus this data point. And accordingly, all other values will get updated. So you can see that we have got new values here. And these new values are, you can see these new values are for the centroid value 1 and for the centroid value 70.5. Now again I'll compare. I'll make the comparison which one is which one is the lower distance. So 0 is lower, 1 is lower, 25 is lower, 31 is lower, 61 is lower. So we have some updates in the values. So what updates do we have? The updates we have is, we have 1 and 2, these values in the cluster 1. So I'm putting them over here. And we have 45, 102 and 132 in the second cluster. So you can see that we have change in the cluster, right? So earlier cluster 1 was having only the value 1. And now the cluster 1 is having 1 and 2 value. And the cluster 2 is having 45, 102 and 132 values. So this is a change which we have seen. Shall we stop here? No, we cannot stop here. If you find a change, you need to continue. If you don't find a change, you can stop. That is the rule, that when you don't find any change in the center values of the centroids, and if you don't find any change in the cluster 1 elements and cluster 2 elements, you can surely stop at that particular point of time. But here we have new center points. So C1 has been updated and it is 1.5. And accordingly, I'll have to put the formula that absolute value 1.5 minus this value 1. So this is the new formula which we have. And let me extend it across the whole of the columns, rows here. And now in the second case, I will have absolute value and 93 minus this particular value. So this is the distance which we have, and let me stretch it out. So here you can see, here we have 93 is the average. So we have updated values over here, and again we will make a comparison. So let's make a comparison, which one is the lower value and which one is the higher value. So 0.5 is lower, 0.5 is lower, 43 is lower, and 9 is lower, and 39 is lower. So we have got the updated values. And what is the update here about the clusters? Update is that 1, 2 and 45, they are now in the cluster 1, 102 and 132, they are in the cluster 2. This is my iteration 3. Shall we go ahead and do more iterations? Yes, because that's the rule. Because still we found some changes. Till the time the changes are not getting repeated, we keep on, need to make such things, such iterations. So let me basically have here iterate iteration 4, and in the fourth iteration, we have the updated values for the centroids, and the first centroid value is 16, and centroid for the cluster 2, the value is 117. So these are the values we have got. Now let me do changes in the formula. Absolute value from 16 minus, I have to minus this particular value, and similar way here also absolute value I have to take, and 117 minus this particular value I need to do. And let me now expand these rows throughout the available rows. So these are the new values which we have got. Now again make a comparison. What comparison will you make? Again, which one is lesser? This one is lesser, this one is lesser, and 29, even 29 is lesser. So first three values are lesser, these two are higher, they are larger. Now try to understand what is happening here. The cluster doesn't change. C1 is already, it was having 1 to 45, it is still having 1 to 45. C2 is having 102 and 132, still it is having the same values. This means that we have reached to the final cluster, and this is the final cluster which we have. Now you don't need to do more iterations. This is what is k-means algorithm. It tries to identify k and then means, and it computes the means iteratively till the time means doesn't repeat themselves. So these are the final clusters. So the same thing we will see in the implementation part also. I hope you like this particular tutorial. Thank you very much.